All right, y'all, we've got two operations to talk about for rational expressions today. We are learning how to multiply and divide rationals. Okay, and we're going to start immediately with an example, multiply rational expressions. So go ahead and get this example down. We have 2x minus 8 over x squared minus 16 times x squared plus 5x plus 4 over x squared plus 8x plus 16. All right, and the first step that we're going to start with is factor everything. Factor everything. So like I said, we need to be really good at factoring for this unit, and we're going to start by factoring every single piece. So that means the numerators and denominators of both expressions here. So let's go ahead and do that. I'm going to start with the factors for 2x minus 8. Those factors, we have a GCF, so we get 2 and then x minus 4 over, and then we're going to factor the next part, x squared minus 16. That factors by difference of squares into x plus 4, x minus 4. Leave the operation, the multiplication, that dot right there in the middle, and then go ahead and factor our next numerator, which factors into, okay, we're going to talk about how to quickly factor this. First of all, we know that it's going to turn into two factors. And factors, usually, if there's no value out in front, if there's no a value, the a value is 1, there's no number out in front, then the factors are both going to start with x, always. And then you're going to have a positive or a negative, right? And these numbers, the numbers that go here, are the numbers that multiply to whatever you need to c, or a times c, sorry. So that would be multiply to 4, and add to the b value, which is 5. We're looking at multiplying to 4 because it's 1 times 4 and adding to 5. Okay, so what numbers multiply to 4 and add to 5? Well, that would be 4 and 1. Cool. And now the last step that we need to do is figure out, is it a positive or a negative 4 and 1 that would multiply to 4 and add to 5? And both of these need to be positive. So there we go. Look at that. We factored without using the box. Cool. And then the last thing we need to factor is this final denominator. So let's go ahead and factor that. I'm going to do it the exact same way that I just showed you. So the a value is 1, right? So this value out in front of the x squared is 1. So that means we can use this method to factor. And both factors start with x. We need to multiply to 16 here for this bottom one and add to 8. So what can multiply to 16 and add up to 8? That would be 4 and 4. Do they need to be positive, negative, negative, positive, both negative? Well, to add up to 8, they both need to be positive. Sweet. Okay, so we're done with step 1. We factored all pieces. Now step 2. Step 2 is we could, you know what, let's add to this. Factor everything and then draw the line across. And this is like kind of my own step, so I'm going to show you what I mean by this. We're going to take this line right here, and we're going to complete it. Because this operation's multiplication, we can basically turn this into one big fraction. Because it's multiplication, you multiply the numerator and the denominator, and it turns into one big fraction. So how am I going to represent that? I'm going to draw the fraction line all the way across. There we go. Okay, so now we basically have one big fraction. These are separated by multiplication, just like the other factors. Sweet. So now let's move to step 2. We are going to write the excluded values. And we talked about these values yesterday. Excluded domain values. So remember, the domain is what x equals. The excluded domain values are what x is not allowed to equal, and those come from whatever make the denominator equal 0. So let's go ahead and write those, and we're actually going to write them at the bottom because they're going to be a part of our final answer, but you need to do it in step 2 before we move on. So let's go ahead and write those down here. We're going to write them down here. X is not allowed to equal. All right, hold on. We'll write them here. X is not allowed to equal, and we are going to look at these factors in the denominator and say what x isn't allowed to equal. The way that we do that is find the zeros. So for this first factor, the 0 is x equals -4. Because that would make the denominator equal 0, we are not allowed to equal -4. So down here, we're going to put -4. Cool. And then also, x is not allowed to equal +4. So we would put +4 down here. This one is -4 again. This one is -4 again. X equals -4. So we only have to write -4 once. We already got it down here, so we don't have to write it again. Okay, so our excluded values are down here. X is not allowed to equal -4 and +4. And let me clean this up. X cannot equal -4 and +4. Sweet. Let's move on to step 3. So step 3 is going to be cancel, and you could put in parentheses cross out common factors. Cancel or cross out common factors in the numerator and denominator. So because the operation between each of these factors is multiplication, we are allowed to cross out matching things on the top and bottom. So what do we have? Let's just start from left to right. On the top, we have x minus 4. That we could cross out this x minus 4 because those match. Cool. Do we have another x plus 1? No. Do we have a 2 in the denominator? No. Do we have an x plus 4? Yes. I'm going to cross out this one over here. You can only cross out one like for each pair. You have to make an exact pair to be able to cross out. Cool. So now that we've canceled the common factors, our final step is to write the simplified form. Okay, so write the simplified form. That just means write whatever's left. So what do we have left? On top we have 2 and x plus 1. So we're going to say, okay, this converts to 2 parentheses x plus 1. And then what's left on bottom? We have x plus 4 and x plus 4. So x plus 4, x plus 4. And we can even simplify this further. We have 2 of these x plus 4s. So we could say x plus 4 squared in the bottom. So let's go ahead and do that. 2x plus 1 over x plus 4 squared. All right, your answer consists of this simplified form and the excluded values. That's why we put those at the bottom. So here is your final answer, the 2 things that are boxed. Okay, now let's go into dividing rationals, which actually is very, very similar to multiplying. So divide rational expressions. There's only one different step. So let's go ahead and go over that step. When you're dividing fractions, you could say you multiply by the reciprocal. That's your first step. Multiply by the reciprocal. Okay, that's like fancy math language. So you may have called it copy dot flip or keep flip change. So in parentheses, I'll put copy dot flip because that might be a good way for you to remember it, and I'll explain what I mean. Okay, multiply by the reciprocal means you just turn it into multiplication. So we're going to turn this sign into multiplication, but we're going to flip this fraction. So we will turn this into multiplication and then flip the second fraction. So we think of copy dot flip. Copy dot flip. Sweet, so let's copy the first one. 5y squared plus y over y squared minus 1. I'm literally just copying. Then dot, copy, dot, and then flip the second one. So that means we need to switch the numerator and denominator. So we get 4y squared plus y minus 5 on top. And then in the denominator, we get 10y squared plus 2y. Okay, now that we've done this first step, that's unique to division. When we're dividing, we have to do this. Well, now that we've done that, we've turned the problem into multiplication. So what can we do? We can follow all the same steps as the multiplication problem. So if we look back on our very first step, the very first step was factor all parts. Factor everything. So let's go ahead and do that. We're going to factor the 5y squared plus y using a GCF. That GCF is y. And then we get 5y plus 1. Let's factor the y squared minus 1 using difference, this one using difference of squares. So we get y plus 1, y minus 1. Then we have multiplication, remember, so put the dot in the middle. And then we are going to factor this numerator. This one we actually need to use the box for. Why? Because our a value is not equal to 1. It's 4. So let me draw the box right here. Let's see. I'm going to go off to the right a little bit. Oops. And we're going to draw the box. And we will factor that numerator. So we need to multiply to negative 20. Multiply to a times c. I'll write that down. So it's negative 5 times 4. That's negative 20. We need to add to the b value. That's the value in the middle. So 1. That's the value right here on y. Okay. What multiplies to negative 20 and adds to 1? Let's see. We have 5 and 4. But they need to add to positive 1. So 5 and negative 4. Those can multiply to 20, right? Okay, and now let's go ahead and put our first term. Oops, and y'all, I wrote x's, but look at the variable that we have. They gave us y's, so let me put some y's on those. So we have 4y squared as our x term, negative 5 as our first term, and then negative 5 as our last term. Now let's take out a GCF. So now we're getting our factors. GCF on this line, they both have y. GCF on this line, they both have a negative, and then 1 goes into 4 and 5. GCF on this column, we have 4 and y. GCF on this column, 5 goes into both of those. All right, cool. So we have our two factors in blue. We have 4y plus 5, and then y minus 1. For the denominator, we can factor out a GCF. So the GCF is 2y, and then we get 5y plus 1. That's what's left. Cool. So now let's go back to our multiplication steps. We turned this division problem into multiplication, so that's why I'm saying multiplication steps. Let's go ahead and do the next step, which is write excluded values. Excluded x values. So, or in this case, it's y values because we have y's as our variables. Remember to look to the denominator and let's see what is y, what are the solutions to the factors in the denominator. So this one, we would have y equals negative 1. This one, we would have y equals 1. For that factor, there is a y out in front. So what does y equal when there's a y out in front? 0. For this factor, y equals negative 1/5. Okay, so now that we've got all those, let's go ahead and write them at the bottom just like we did last time because they're going to be part of our final answer. And because they're excluded, we're not allowed to equal those solutions. We're not allowed to equal those zeros. We're actually going to write y is not allowed to equal negative 1, 1, 0, and negative 1/5. And that's because all those values will make the denominator equal 0. If we plug in any of those values, the denominator would equal 0. Okay, so now let's go back to our next step, which is, we forgot to do this, y'all. After you factor all parts, you can draw the line across. For multiplication, you can draw the line across. So I'm going to take this line and complete it all the way across and pretend that that's one big fraction because they're multiplying. Sweet. Now we can cross out common factors. Sweet. Let's go ahead and cross out the common factors in the numerator and denominator. I see a y. That one's usually sneaky, so don't miss that one. I usually start left to right, like in the numerator, and just check. So like, do I see a y? Yes. Do I see 5y plus 1? Yes. Do I see 4y plus 5 in both the numerator and denominator? No. Do I see y minus 1? Yes. Sweet. Once we have crossed out our like terms or our common factors, we can now write in simplified form. So write simplified form. All right, so we just write what's left. On top, I see 4y plus 5. And that's it. And then on bottom, I see y plus 1. Cool. So our final answer, ooh, y'all, I almost missed something on the bottom. This little 2, the sneaky little 2. So let's put that out in front. We have 2 times y plus 1. Okay, because we didn't cross out the 2. Sweet. And our final answer is both the excluded values and the simplified form. So this and my excluded values, that is my final answer. All right, and that's notes for today, y'all.